होता क्या है कि even if you know something, but if you don't know the background, how we have evolved from the starting to till date. So that way, when we have got that idea, the whole line from starting to till date, then we get the clear idea, like, okay, how the things started and what changed, what has already changed during this period of time, and what we are actually working right now. Although whatever the tools and technologies that we are using currently, and we are going to work, like, we are going to do hands-on on all the the latest things that is flourishing in the market itself. So हम कोशिश वही करेंगे कि you should be able to understand it. uh, Vineet, I think one more person has to join today, right? Hello.
Hello.
One more person needs to join today also, right?
Actually, sir, I am Shivansh, sir, new data analyst trainer over here. Vinay sir is not here as of now. Let me ask him.
Oh, no. Actually, he told me like two candidates are going to join today, right?
Okay, sir. Then let me ask with the talk with the second.
Yeah, whether we have to wait for him or we can start. This is what my concern, right?
Sure, sir. Sure, sir.
Because today we most probably we are only going to have this session little, just for an hour, because I have got another meeting at 5, so we'll try to wrap up before that. And as this is going to be the first class, so I don't want to put much pressure on you guys. So you should be able to understand the things very clearly. And the way I try to start the training, and during the training itself, if you find anything that you are not able to get it, or you are facing any sort of issue in understanding, you can just stop me there itself and try to ask me, like, what is it, why we are using this, what is the actual use of this, like whatever your queries are going to be there, we'll try to understand. And might be there are going to be a few things that if you are not able to understand those correctly, so mostly I'll tell you, like, okay, these things I'm just going to tell you for now, but in when we are going further, so we are going to discuss all those things in detail. So at that point of time, you will be able to understand those things very clearly, right? So this way we'll try, but whatever we are discussing, we are not going to leave it open, right? Okay, we have started it and we didn't touch it again. We'll do each and everything with full understanding, right? And most of the things that we are going to do are like within the data engineering itself. Once we're done with the concepts, then we have to do the hands-on. So hands-on is again going to be very specific things that we have to do. And during the whole training, you also need to do lots of hands-on, so that you should be aligned with what we are trying to do, right? क्योंकि देखो, अगर हम कुछ भी सीख रहे हैं और उसकी प्रैक्टिस नहीं कर रहे हैं, so there is no point. Maybe what is going to happen, you will remember all those things for a day or two, or maybe a week if you have got very good memory, right? But after a week itself, if you are not practicing those things, so those things will be wipe out, because we are learning new things every day. So if we are not practicing those ones, so practicing the things can only help us.
Raj sir, both the students have joined.
Both joined. Okay. Arvind. Hey Arvind, how are you? Arvind?
Hello. Audible?
Okay. Can you just share your screen just for a moment, and then once we are going to start, as this is going to be the first class, so let's have a face-to-face, introduction first. And then,
Sir, just a second.
Arvind, can you share a screen?
Yes,
Just
sir, just
not
second. 5 seconds,
just
sir.
you can turn on your video. I just wanted to see your face actually. Like I just wanted to see like to whom I am just giving the training.
Yes, sir. Wait a minute.
And need some little introduction from your side. So, if you know about me, I don't know whether Vineet has already communicated to you guys or not, but yeah, let me give you a brief about myself. So, myself, Raj, I've got more than 15 years of total IT experience, and into data engineering, I'm having more than 12 years. So, I started my career as a Java developer, but after some point of time, what I did, like I thought like, okay, you know you must be you are at the same level right now when I was there in 2008 or so. So I thought after doing for 2.5 years, I thought, okay, what I'm doing, it's not the correct. So I should try for civil services. So I went to I quit my job and start preparing for UPSC. I had given my 3.5 years or four years max. I just did 3 attempts. Even I love. I was I left my fourth attempt also. So, but yeah, unfortunately, I was not able to the interview itself. I have given 3 attempts, and in 2 attempts, I was able to qualify prelims, and in one means also, but not qualified. So then I thought, okay, I should go back to IT, because so at that point of time, I thought, okay, going back to IT might be going to be risky, because during that around 4 years of time, a lot of things has changed in basically within the Java itself. So a lot more updates were there. So at that point of time, I thought, okay, somebody told me because most of my friends are there in the IT itself. So they told me it's better to you should switch to data engineering, because that is going to flourish everywhere. Like if anything is going to be there, data will always going to be there. So it is better to always have got updated on that part. So that's why I just moved to data side itself, and I have started as a when I've just back to IT. So I've started as a a data analyst, and for an year I was a data analyst, and gradually I moved to data engineering part. So from last 7 to 8 years, then from Hadoop to Hadoop technology to Spark, and now we are into Databricks. So I have got more than 7 to 8 years of experience in all the major clouds, whether it's going to be AWS, it's going to be GCP or Azure side itself, right? So we are going to cover all those things. Mostly, most of the things we are going to cover in detail, and mostly we are going to focus. Our focus will be there on the Databricks side. So what Databricks is there? Why we are choosing that one? Because Databricks is a unified platform where, irrespective of any cloud, whether we are working with AWS, GCP, or Azure side, it has got all the clouds which are integrated with Databricks itself. So that's why we will mainly going to focus, and we don't have to depend on multiple services. All the services are unified at one place within the Databricks itself. So that's why if you talk about in last 4 to 5 years, Databricks has flourished a lot. And if you even talk about Fortune 500 companies, so 80% of the the services are being used by the Databricks itself. So that's the the marketplace where the Databricks stand right now, and definitely in future also it's going to do better. Okay, so that was my introduction. Although when we are going to have the discussions, so we'll talk about more on these things. So yeah, Arvind, what about you? Like what you are doing right now? What's your exposure to?
Current, hello, sir. Good afternoon, sir.
Mm-hmm.
Currently, I am pursuing BTech graduation, BTech in CSC department, and
You are-
I
you
am
are-
in my final year.
Okay, you are in your final year, right?
Yes, sir.
Okay, fine. That's really a good, like starting point itself, because even if you are when you are going to sit for your interviews, so definitely if you know something about Databricks and data engineering part, so that's really going to help you to get a better advantage from the other people.
Yes, sir.
So that's really good to know that. Okay, you have even in your early stages, you are trying to pick up all those things.
Yes.
Good. Okay. So now I think we can get started. So we'll start from understanding, what is data engineering, and we'll try to understand the background of, before even going for the data engineering, what is exactly the data? What data is? What is big data? We should be able to understand. Okay. So let me just. Okay. Now, if you want, you can just turn off your cameras. That's completely fine. Okay, so let me share my screen, and let me know once you are able to see my screen. Is my screen visible?
Yes, sir.
Yes, sir.
And before we start, one more thing I just would like to request you, like, so I want this session to be interactive. So if I'm asking you something, just let me know whether you know this or don't know this. If you have any questions, any queries, just stop me there and raise your queries, right? Don't wait for the session to end. So I don't feel good, like if you are like, I don't want that you should stay just be ready with your questions, and you are not asking until we reach to the end of the session itself. No, wherever you feel that you are not getting it, just stop me there and raise your questions, right? Okay, so
Okay, sir.
okay, thank you. So we'll be starting with the data engineering part, but before even going for the data engineering, we need to understand what is data. And even once we know data, then we should also know what is big data. So what do you understand by data? Like you both are like, Arvind is in final year, so he must have encountered this data a lot of times, and Divesh is also working, so worked in data, even Oracle side itself. So what do you understand by data first? Any thoughts, like whatever you think, okay, this is data.
Basic, sir, data means that any user data, like जैसे कोई भी जोमेटो कंपनी है तो उसमें जैसे यूजर का डेटा होता है, जैसे फोन नंबर, उसका नाम हो गया, उसका एड्रेस हो गया, ये पर्टिकुलर जो होता है उसको हम डेटा कहते हैं.
Okay, fine. Any other
और
thoughts
बिग
about it?
डेटा और
So there one more thing, data and information, right? You also have this information. So is there any difference between data and information?
Yes, sir.
Okay. What is the actual difference?
सर डेटा वो हो गया जो भी हमारे अराउंड है, वो हर एक डेटा है, और उस डेटा से जो हमको यूजुअली हमें जो इम्पोर्टेंट चीज है जिसकी हमें इंफॉर्मेशन चाहिए उसको बोलते हैं इंफॉर्मेशन. डेटा से ही इंफॉर्मेशन निकलता है.
एग्जैक्टली. सो जो हमारा डेटा बेसिकली क्या है, वो रॉ, अगर हम डेफिनेशन की बात करें तो रॉ फैक्ट्स एंड फिगर्स, एनीथिंग लाइक यू कैन टॉक अबाउट द नेम ऑफ ए पर्सन, एज, what he eats, anything, right? Anything related to what he wears, where he's working. So everything is data. But information is what when we are organizing something in some format, so that it is giving us some sort of meaningful information. Basically it is revealing some sort of meaning, then we call it as information, right? So everything is data. So nowadays, like if you talk about how we are generating the data, so data is getting generated from any of the sources. The data is coming from social, social media is one of the and Facebook, Twitter, X. Basically now it's X. Previously used to be the Twitter, and then we have got Instagram. So these are some of the social websites are there, social mediums are there, from which we are getting the news data is there, IoT data is there. Data is getting generated whenever even you are going to from one city to another city, and you are using some sort of uh, GPS. So there also you are generating huge and huge amount of data. So every day we are generating lot and lots of data. So why we are what is the difference between data and big data? So big data is the term coined when the data becomes so large that it is not able to we are not able to basically uh, uh, basically capture it or do processing on that data. Then it becomes a big data. So big data is basically, you can say it was a problem statement at that point of time. I'm not talking about right now. Right now we have a lot of huge different tools are available that we can say okay, these are the the big data tools which can handle this big data very efficiently. So we'll talk about it, right? So let me just give you yeah. So let's so we'll be talking about what is big data. So when we are saying big data, it's lots of data in coming in terms of terabytes or petabytes. Then we are calling it big data. Why? Because if you talk about the traditional database systems, like when we are talking about Oracle, SAS, or ETL, any of the Informatica, so they can handle these even terabytes of data, or even few thousand gigabytes of data. But when it goes to petabytes or zettabytes of data, so these systems got failed because these systems are not able to capture this data, store data, search. So why we are storing these data? Because we have to do some sort of transformations. We need to do analysis, visualization on top of it. So when our traditional systems are not able to cope up with this huge amount of data, then we are calling it as a big data. So big data is the term for the collection of data sets so large and complex. Now large, you understand, large in terms of terabytes, petabytes, zettabytes. But what do you mean by complex here? Complex means the data that we are generating right now, this is not the structured data only. Previously we used to, like if you talk about SAS or Oracle itself, so there we are basically processing structured data only, the data which is coming in terms of row and columns in the form of tables, like CSV data, or we have got some Excel data, tabular form data. So that data is fine, but that data is not that much complex. Complexity comes like when we are dealing with semi-structured as well as totally unstructured data, like audio files, video files, images. So these kind of images we are not able to process it from our on hand traditional systems. Like, are you able to perform, can you just process videos from your MySQL server or MS SQL server, or any like Oracle itself? Are you able to process that data? No, we can't process that data from the traditional. So therefore, we are going to have a lot of challenges. So what challenges are going to be there? How we are going to capture it? Curation means how we are going to maintain it, storage, searching, sharing, transfer, and doing all sort of analysis and visualization. So if we are not able to do that, then that data we are calling it as big data. So big data was a problem. So again, the data is coming from different diverse data sources. It can come from let's say how we are generating this huge amount of data. So different organizations are generating different. Amazon, every day more than 1,000 million in billions users clicking on those websites on different products. So every time you are just clicking on any of the links, so you are just passing on some sort of your data, user data is getting captured. So this way we are generating huge amount of data. Stock market is generating few few thousands of terabytes of data on daily basis. Then emails, we are just exchanging emails, sending emails. So more than 1,000 billion emails are getting sent on everyday basis. So every time we are generating data in terms of petabytes. So these are few other, apart from this, like we have got IoTs nowadays, Internet of Things. Every nowadays the things become so smart. Like every devices are getting smarter and smarter. So we should be able to generate huge amount of data. Okay. So this is basically one of the it's quite old, but right now I'm going to tell you the latest the scenario is there. So when we were generating the data, so most of the data that we started generating was a structured data, but gradually we find that the data that we are getting generated, the mostly data that we are getting generated is in unstructured format, right? So it was supposed to suppose that like the world's information is getting doubled every 2 years. So it was supposed at that point of time in 2006, around 2015 to 16, this estimation was estimated that by 2020, everyone on the basically Earth is going to have around 5.2 around 5 terabytes of data for each person. Then this was an average, but when they actually reach out to 2020, it was more than that. They were having around 7 terabytes of data, which was an average. But now, with the introduction of these smart devices, especially the smartphones, everybody's creating a lot of unstructured content on the different platform itself, whether it's going to be Facebook, Twitter, or it's going to be Instagram, or you can say WhatsApp is there, and news contents are getting generated huge, and peoples are even creating their own lot of content. They're creating videos, audios, and sharing with the the groups itself. So huge number of data is getting generated on daily basis, right? Now, so initially this was the definition. This you need to understand this, right? So what defining what is exactly defining what is big data? So initially when this big data term was coined, so they have included three parameters to define that, okay, this is going to be big data when my volume of the data is getting increased exponentially. So this was a problem to handle huge volume of data. So this was one parameter. Then another was the velocity. Velocity means at which speed, at what speed we are generating the data. So if we are going to keep the time constant, so that if my volume is increasing, then how it's basically the speed. So the data which is getting generated at what speed. So it was again going to be exponential, because we have just fixed the time. So if velocity is increased, volume is increasing, so definitely because its velocity is getting increased. Then the third point was variety of data. So initially there was people used to work on structured data itself, but we were not generating only structured data. We are generating web logs, audios, videos, image, sensor data. Even if you talk about, let's say, when a plane moving from just half an hour flight, in one plane we are having more than 6,000 different sensors are there, which basically capture different forms of data. So within just half an hour flight, a flight basically generates around 1 terabyte of data. So you can imagine how many number of flights are running. Even some of the flights are continuously running for hours, like 10 hours, 20 hours, like from Delhi to New York. A direct flight generally takes around 15 to 17 hours. So you can imagine how much data that just one side flight is getting generated. So this is one way, like how we are generating huge amount of data. So processing that data is again going to be a bottleneck, right? So keeping these parameters like volume, velocity, and variety in a huge way. We call it as a big data because these were the three problems, like how we are going to handle this huge amount of data, how we are going to handle the speed of the data, and how we are going to handle this variety, different forms of data. Because my weblogs, audio, images, videos, these are going to be very unstructured data format. Sensor data could be like in the form of structured data sets, right? Then after some point of time, they found out, okay, we are also struggling with the data which is called veracity. Veracity is the like wherever for some period of time you have got your data is available, but for some portion of time we don't have that data. So wherever we are not having the consistency is not there within the data itself. So again, processing this inconsistent data was again a bottleneck for the traditional systems. So there they were putting a lot of different algorithms to mean, median, mode, or putting some sort of missing values. So those kind of stuffs they used to provide, but that was applicable for certain volume of data. But here when it becomes again the huge data set, so again it became a bottleneck for the why we are saying bottleneck, because again even if we are able to store a huge amount of data, the problems comes how we are going to process it, right? So processing was again, but even processing the data which is not consistent, again it is going to be another bottleneck. So then they have introduced one more V, which is called as veracity. So now at that point of time, from 3 to 4 V's were getting added. Now they have added one more V, which is called value. Now we have got one more V, which is called value. So whatever data we are adding, if that data doesn't have any value, this is not giving any sort of information or any sort of value, then why we are going to store it? So that's why this is one of the important parameter becomes like, if we are processing anything and if we are not able to get any valuable inputs from that value, then why we are using that value? So that's why this is one of the the important thing that they have introduced recently, like in last 5 to 6 years itself. Before that we were only using these 4 V's, and before that also we were using only 3 V's as a definition of big data. Like from the starting itself, these 3 V's were the definition was used to define the what is big data. So volume, variety, and velocity and variety, then introduced veracity, and now they have introduced value. So we have to get the we have to find out the value. Like we are processing this huge amount of data in terms of terabytes, petabytes, even in zettabytes of data, and if we are not getting the insight of that data, we are not finding out the value out of it, and there is no point, right? So that's why this value is going to be very good parameter to define big data. Clear? So any questions, any queries so far, please let me know. Or and also just tell me whether are we going faster, slower, or this speed is fine. Please let me know this thing also, so that we can just make our speed according to your capacity, right? If you think we are going little slow, so we can go little faster. If you think we are going very fast, so we can be a little slower, right? Then there are certain big data customer scenarios where big data played a very good role in identifying the the user issues, like recommendation engines. You will find a lot of times, like if you have clicked on a particular a product, so every time that similar kind of products are going to be recommended for you. So how they are able to do it, because they have got huge database are there, and based on your preferences itself, next time if something is going to be have the similar sort of product, so they are going to recommend you the same. Or if you have a click on a particular kind of ad, so every time you are going to get the basically now the recommendation engines or the systems become so intelligent, like they are able to understand what you are thinking about that product. So a lot of people, that's why as nowadays company used to take the reviews on every product, so that they can understand the psychology of the people behind that product, so that they can come up with with new ideas or new schemes, so that they can make their product better, as well as sales can go up, right? And search quality. So if we are, let's say, we are having a our database is having 1,000 records. So if we are searching a common thing within this 1,000 records, are we able to get the good search? But if we are searching, let's say, within 1 million records or 1 billion records are there, like data set, different data sets are there. So there we will be able to get the best search possible, because when we are having low amount of data is going to be there. So basically my search, the periphery is going to be very little. So maybe I won't be able to get the correct search what I was trying to find out. But if we have got very huge like ocean of data is there, so let's say if I'm just getting the searching it within a pond itself, and if I'm searching within an ocean itself, so where you are going to get the more number of let's say species, definitely within the ocean itself. So there you will able to find out some your search quality is going to be get increased. Then like abuse and click fraud detection. So this is one of the important use case that really helping to detect fraud. It generally used to detect fraud transactions. So previously people used to get even though right now also, because these scammers are think in different directions. They have got very good minds, but they think in very different directions. They think in opposite directions to make easy available money, but they don't know, like the people's they are losing. So this abuse and click fraud detection generally used to get safer from these kind of cyber crimes. So generally what happens, like if you I don't know whether you have encountered any sort of this issue or not, but like if you are making any sort of transactions and if that transaction is little seems to be little bit awkward from your previous transaction. Let's say you generally used to make transactions up to 5,000, but suddenly what happens, like you made a transaction of, let's say, 50,000. So before even making the transaction complete, you will get a confirmation call from the bank itself, like whether you are the person who is making this particular transaction, and this call is going to be an automated call. Automated call means like automatically a signal goes to the concerned person, and they generally give a call back on your number to just confirm whether whatever you are the correct person who was making this transaction. Just give me a moment. I'm getting a call. Yeah. So sorry. Then within the telecommunication itself, we have got customer churn prevention. Means like if nowadays the telecom companies, they are trying to retain their customers by giving them better performances, like network performance optimization. So within the area itself, if something is going to be there within the network, so they inform in advance, okay, during this period of time might be you are going to face some sort of network failures, or even in advance they will get to know all these things and inform the client itself. And also you can get the CDR analysis whenever you are required. So because based on the CDR itself, nowadays you see a lot of criminal cases or fraud cases are getting resolved. So these kind of informations are available, or these are the very good scenarios. Apart from this, you will find a lot of different scenarios are there in my industry where we are facing these kind of issues. So these were only related to web and e-commerce sites or telecommunication site. But if you go to the other areas also, you will find different use cases that are being handled, right? Okay, so yeah, so before we move further, let me ask you, like, any questions, any queries do you have so far?
No, sir.
So whatever we have discussed so far, are you able to understand?
Yes, sir.
Okay, that's good. Good to hear that. So now I'm going to share this, story. Basically, this is not a story. This was a, the analysis or the testing which was done back in 2006, when this was the start of big data. So Shear Corporation, it's a basically a, organization which used to do some sort of analysis on other companies' data. So what they were trying to do is, like, they used to process huge amount of data at that point of time. So they were thinking about the future. Like in 2006, if you talk about, so generally people at that point of time used to take, let's say, 100 GBs of data, 200 GBs of data, even in terabytes of data. They used to take it. Okay, that was a huge amount of data. And are there traditional systems like SAS, Oracle's Exadata, or Teradata, were they able to process this huge amount of data? So yeah, Teradata was able to process up to 20 terabytes of data. Oracle can process 10 to 20 terabytes of data. SAS was able to process up to 10 terabytes of data. So that was fine. They were able to process it. But the Shears was thinking about the future. Like, okay, as at that point of time, the data was growing at a very high speed, exponentially data was growing. And we have got complex data. The data was in terms of audio, video, images, logs, or IoT data on that start fulfilling at that point of time. But it was not there at, but other parts of data, forms of data was available. So they were thinking about the future, like what is going to happen in, let's say, 10 years down the line. Are our systems are capable enough to handle this huge amount of data? So what they did is, like, they did an analysis on 2 terabytes of data. So you can understand 2 terabytes is 2048 uh, GBs of data. So 2 terabyte is fine. Like, even as I told you, Teradata in Oracle X, they were able to handle 20 terabytes of data. So they thought, like, during the after 10 years or so, our data size could be in petabytes. So they took 2 petabytes of data for their processing. So when they just tried to handle this processing, so their traditional systems got failed. They were all got failed. Why they got failed is, let me give you an example. So basically, what we have got the limitations on our existing data, base structures. So what we used to do is, instrumentation layer is the layer, like, it's the source layer, like from where we are gathering the data and then we are collecting the data. So within the traditional systems, what we have got one storage layer, like where we are going to store our traditional data, like all the data. So one was storage layer where we are storing the data. Another layer was the ETL layer, or the compute grid, where we have to process the data, right? So when we are moving the data from storage to processing, So mainly the three issues that were getting happened was like 2 petabytes of data. So you can imagine 2048 terabytes of data. They were just moving from storage to ETL. Only then, because we have to move to the ETL grid, then we'll be able to, because storage was different and the processing was different. These were two different layers, and like data we cannot put in the form of, let's say, suitcases, and we can send it and bring it to the ETL itself. It has to go through some sort of network, right? So when we were sending the data, so first thing was like we cannot explore originally high fidelity raw data. Means what? Like whenever we were moving the data from storage to compute grid, where the processing was happening, we were not able to get the original data. Original means like there were some sort of issues, like some corruption or encrypted data that we were able got encrypted. Some masking happened automatically, and that basically did your data corrupted. Like sometimes you will see, even if we are sending some, if you I don't know whether you have faced this any time, like when you have sent some, even some few kbs of message from your phone to your friend, so sometimes the data comes out to be in some encrypted format, right? Because during the transmission, there's sort of some network failure or something happens, because of that your data got corrupted. But here we are sending 2 petabytes of data, so there might be the chances there could be issues with the network bandwidth, there could be the issues with the other stuff can be there, which is basically creating this data, that what data we were trying to send, we are not getting the data in the same format, right? So there can be multiple issues can be there. Another issue is like when we were sending the data, so we were not getting the same amount of data. So moving data to compute does not scale, means we have sent the data, we are sending the 2 petabytes of data, but we just got around 10% of the data. You can just take the reverse example. Let's say 90% data we are able to get, even just 10% of data got filled. So 2 petabytes of 10%, how much it is going to be there? You can think about it. It's going to be huge amount of data, right? So definitely the results are not going to be correct, because how much that data is going to impact, we don't know. The third one was there, premature data death. Premature data death means like generally what happens is when we don't have this big data, or the when we talk about traditional systems, so these all like Oracle, Exadata, Teradata, SAS, these are all what? These are all servers, and servers come up with a lot of cost, and they are centralized systems were there. So they have got some fixed amount of RAM is there, fixed amount of storage disks are there. So if we have to increase it, let's say I need to initially I've started with, let's say 500 GBs, or let's say 10 GB 10 terabytes of data. So if I need to add 10 terabytes more, I need those are coming with the lot of because these are the servers, so servers are going to be there with a lot of cost. So if I just talk about, let's say 1 terabyte of server, so it is, if I'm going to talk about the servers at that point of time, it was costing in few lakhs to get us just, let's say 10 terabyte to 50 terabytes, even 100 terabytes of it. So it was costing in around 50 lakhs of just to get it, and then we have to maintain those, so maintenance cost is again going to be there. So a lot of other additional costs were included. So yeah, if we have to increase this thing, definitely. So premature data, that means like taking this consideration. So what generally people used to do is like they used to have only the latest data, let's say last 2 years of data, or let's say last 7 years of data maximum. Like if I talk about the example of hospitals, so hospital used to only store last 7 years of data. Before 7 years of data, they automatically used to it goes to archival. like automatically it got deleted once the 7 years got completed because of this, storage limitations on the server itself, right? So if you go before big data, if you go to and you wanted to check, let's say, I wanted to check my last 10 years, what happened in my last 10 years. So if I need to get all those details from the hospital itself, at that point of time, you are not able to do it. Understood? Like three problems, all the three problems you were able to understand. Cannot explore high fidelity raw data. It means the data got corrupted because of multiple reasons. We are not able to scale because, let's say, my network bandwidth or some sort of failure are there. So we are not able to scale the same amount of data for the computation itself. And third one is the premature data death because of the storage limitations on the server itself. Understood? All the 3 points?
Yes, sir.
Yes, sir.
Okay. Yeah, I just need your, yes, no, whatever. If you're not understanding, just let me know. But I want to have this session, if I'm just talking myself, so might be you feel a little bored, right? Although I tried to make it little, lighter, but yeah, still it can be there. Like even if I'm just listening, so sometimes I feel sleepy. So that should not be the case, right? So what solution is come up from the Hadoop itself? So what Hadoop does is, like, they have bring storage and compute at the same layer. Like, so what they told, like, we are not moving the storage itself. We are just bringing the compute to the storage itself. Yeah, just tell me one thing. Like, I'm having, let's say, 500 terabytes of storage data that I need to process. So I need to do some sort of processing. So what is going to be the processing? Like, what will the size of the processing? Processing is going to be, let's say, some of your SQL scripts can be there, some Python script can be there, some PySpark script can be there. So it can be in few MBs. Like if it is going to be a whole process itself, it can be in, let's say, maximum in 1 GB. Like if it is going to be the whole application itself, but it is not going to be there in few GBs itself, or not in hundreds of GBs, right? So sending processing to the storage is going to be little cheaper, right? Sending, let's say, 2 petabytes of storage from storage to compute grid is quite expensive, as we have seen. But just sending the compute to the storage itself, it is going to be quite easier. So instead of sending, so what we did is, as a part of big data, we are not moving storage at all, although we are bringing the compute to the storage itself. Like हम ये बोल रहे हैं कि भाई जहां हमारा स्टोरेज है हम वही प्रोसेस कर देते हैं. वी आर नॉट मूविंग अवर स्टोरेज एट ऑल. तो जब स्टोरेज मूव ही नहीं हो रहा तो हमारे तीनों प्रॉब्लम सॉल्व, पहले 2 प्रॉब्लम सॉल्व हो गए, क्योंकि जब डेटा मूव ही नहीं हो रहा देयर इज नो पॉइंट कि उसमें डेटा में कोई चेंज आएगा, कोई इंक्रिप्शन हो सकता है, कोई या फिर कोई वायरस अटैक हो सकता है. डेटा जहाँ है वहीं पे पड़ा हुआ है. देयर इज नो बेसिकली वी आर नॉट मूविंग द डेटा. अनदर नहीं, जब डेटा को मूव ही नहीं कर रहे तो जो डेटा है वो एज इट इज रहेगा. सो देयर इज नो स्केलेबिलिटी इश्यूज. थर्ड प्रॉब्लम कि भाई हम डेटा को व्हाई वी आर नॉट आर्काइविंग द डेटा. तो इसमें क्या है कि हम यहाँ पे हडूप का यूज कर रहे हैं, एंड हडूप इज अ डिस्ट्रीब्यूटेड फाइल सिस्टम. I will understand what is distributed file system. If you have got the idea, that is really good. Even if you don't have, so we are going to discuss this thing. So here we are not storing the data on a single machine. We are storing the data on multiple machines. So यहाँ पे क्या किया, share move to a 300 node Hadoop cluster. अब Hadoop cluster क्या है, node क्या है, that will understand. But now here we are using 300 different machines. सो जहाँ पे हम एक मशीन पे डेटा को स्टोर कर रहे थे, अब यहाँ पे हम 300 मशीन पे स्टोर कर रहे हैं, एंड डेटा इज डिस्ट्रीब्यूटेड. सो देयर वी वर जस्ट गेटिंग 10% ऑफ द डेटा, बट हियर वी आर एबल टू डेटा 100% डेटा इज अवेलेबल फॉर प्रोसेसिंग, राइट? सो ऑल ऑफ माई 3 issues got resolved. But now your questions comes out. सर यू आर टॉकिंग अबाउट कि हम एक मशीन है, दैट वाज अ सर्वर. सो वहाँ पे हमारा कॉस्ट बढ़ रहा था, तो यहाँ हमने 300 मशीन को यूज़ किया, तो यहाँ पे हमारा कॉस्ट नहीं बढ़ेगा. वैलिड क्वेश्चन, राइट? बढ़ना चाहिए. But here we are not using dedicated machines or servers. Here we are using cheap machines. Cheap machines means low cost. इनका cost बहुत कम है. Let's say 1 terabyte, 10 terabytes maximum machines. So, and those are only the the CPUs. They don't have any sort of screens and all visuals. They don't need, because we have to process in background. We only need one machine where we can just see the data, how much amount of data is there. So that way we are doing it. But here 300 node Hadoop cluster means we are using 300 machines, but cheap machines, which can down at any point of time. जो हमारा सर्वर होता है वो डाउन होता है. आपने सुना ही होगा जब आप किसी let's talk about the example of banks. आप जब भी कभी बैंक में जाते हो तो you must have seen, especially in government banks, you will see server down है. यही बोलते हैं ना every time, server down है. The server is down. So even servers got down. This is rare. They got down. But here we are using 300 node cluster. Or here why? अब दूसरा क्वेश्चन आता है, if those are, जब सर्वर हमारे डाउन हो जाते हैं तो यहाँ पे तो we are working on commodity hardware, which is cheap hardware, low cost hardware. तो यहाँ पे भी तो डाउन होगा, definitely डाउन होगा. But here we are maintaining 3 applications. Replication यानी कि जो डेटा मेरा एक मशीन पे होगा, सिमिलर डेटा मेरे बाकी 2 मशीन पे भी होगा. तो अगर मेरी एक मशीन डाउन हो गई तो आई कैन गेट द सेम डेटा फ्रॉम द अदर 2 मशीन्स. 2 डाउन हो गई तो आई कैन गेट इट फ्रॉम द थर्ड मशीन. अब तीनों की तीनों मशीनें डाउन है. दिस इज गोइंग टू बी द रेयर केस. व्हाई? विल सी दिस, राइट? सो फर्स्ट वी अंडरस्टैंड व्हाई DFS. DFS इज डिस्ट्रीब्यूटेड फाइल सिस्टम. पहले हम समझते हैं क्यों यूज कर रहे हैं. फर्स्ट थिंग है कि अगर हम व्हेन वी हैव टू रीड 1 terabyte ऑफ डेटा फ्रॉम वन मशीन, सिंपल एग्जांपल, ऑलमोस्ट मशीन सेम है, 4 input output channel है, each channel can process around 100 MBs per second. सेम स्पीड हमारी हो, बाकी 10, अगर हमें 10 मशीन से प्रोसेस करते हैं तो कितना डिफरेंस आएगा. तो इसको लगेंगे अराउंड एक मशीन को 43 मिनट्स. तो 10 मशीन को कितने लगेंगे? एवरेज में मान लिया 4.3 मिनट्स, राइट? सो यू कैन इमेजिन कि हमारा जो डेटा है वो कितना ज़्यादा फास्ट प्रोसेस हुआ, क्योंकि ये पैरेलल में प्रोसेस हो रहा है हमारा डेटा. यहाँ पे एक ही मशीन प्रोसेस कर रही है तो 100 MB लेगा, फिर प्रोसेस करेगा, फिर 100 MB, फिर पर सेकंड के हिसाब से इट इज कैप्चरिंग द डेटा एंड processing it. But here we are just taking this example, right? Now, so here we have to understand here is Hadoop first. अब ये जो हम आगे Spark की बात करेंगे ना, जो actually में आज यूज हो रहा है, that is the extension of Hadoop only. So that's why we are trying to understand what is Hadoop. Although आज अगर आप किसी इंटरव्यू के लिए बैठते हो तो right now we are having around maximum 10% of the companies are there which are still using on Hadoop. और वो कौन सी कंपनीज है? जनरली those are the banks जो कि still they are using some sort of mainframe systems. अभी वो they have not moved to the latest technology. Still they are using it because of some sort of security issues, data breach. They are working on their own dedicated servers itself. On-premise servers है जहाँ पे अभी भी they are using mainframes, so Hadoop use कर रहा है. Even most of the people, those who are working in TCS itself, they are still using, because I have got few friends are there, they are still using this Hadoop. But overall, if you see, only maximum what I can say is 10 to 12%, or maximum. I don't have the exact the number, but I think it won't go beyond 15% of the still they are using Hadoop. But yeah. That's why we have to understand this. In some of the organizations, they can ask you, even not directly, but they will try to understand that whether you understand the the architecture behind it, right? So जो हमारा Hadoop है वो एक framework है which is allows for distribute. First you have understood the distributed processing, कि हम एक मशीन से प्रोसेस नहीं कर रहे हैं. Our data is distributed to मल्टीपल मशीन्स, और मल्टी मशीन्स पे हमारी प्रोसेसिंग पैरेलल हो रही है, पैरेलल प्रोसेसिंग हो रही है. सो इट अलाउज फॉर डिस्ट्रीब्यूटेड प्रोसेसिंग ऑफ लार्ज डेटा सेट अक्रॉस क्लस्टर ऑफ कमोडिटी कंप्यूटर्स. हम यहाँ पे देखो कमोडिटी कंप्यूटर्स यानी कि चीप हार्डवेयर यूजिंग ए सिंपल प्रोग्रामिंग मॉडल. और वो प्रोग्रामिंग मॉडल क्या है? दैट इज MapReduce. विल अंडरस्टैंड इट लेटर. तो हम एक प्रोग्रामिंग मॉडल यूज कर रहे हैं कि जो उसको प्रोसेस कर रहा है, जो कि हमारे डेटा है डिस्ट्रीब्यूटेड अक्रॉस मल्टीपल मशीन्स यूजिंग कमोडिटी हार्डवेयर टू प्रोसेस देम पैरेलली। सो अब ये क्या है कि ये जो है हमारा Hadoop है, ये ओपन सोर्स है बिकॉज इनिशियली इट वाज स्टार्टेड बाय अपाचे इटसेल्फ, सो दैट्स व्हाई it's an open source, right? And what it is does is it's called scale out storage with distributed processing. Scale out का मतलब क्या होता है कि आज हमने अगर 100 machines use की हैं, so tomorrow if we want to increase it, we can increase to 200, 500. Even Yahoo has checked for 12,000 machine cluster, मतलब एक cluster में 12,000 machines तक वो लोग check कर चुके हैं, and it is working fine. And there is no downtime on this. आप आज 1000 मशीन पे कर रहे हो, कल को आपका डेटा बहुत ज्यादा बड़ा हो गया तो यू कैन ऐड 100 more machines means you can add 100 CPUs and then you will be able to process it without any downtime. आपको उसको सिस्टम को डाउन करने की जरूरत नहीं है, ऑटोमेटिकली it will scale up, right? So this is how the Hadoop works. So ये हमारे Hadoop के key characteristics हुए. First thing, reliable. How it is reliable? अब if you have understood, then you will be able to answer all these questions. Let's start with economical first. Why we are saying it is economical? Arvind, Devesh. बोलो यार.
सर कोई आइडिया नहीं है.
अभी बताया था ना मैंने, कमोडिटी हार्डवेयर, राइट? इकोनॉमिकल का मतलब क्या होता है? चीप है. क्यों है चीप? क्योंकि हियर वी आर नॉट यूजिंग सर्वर्स. हम क्या यूज कर रहे हैं? जितने में एक सर्वर आता है उतने में हमारे हजारों मशीन आ जाएंगी. दिस इज यू कैन अंडरस्टैंड, राइट? जितने में एक सर्वर आएगा उतने में हमारा हजारों सिस्टम्स आ जाएंगे, राइट?
यस सर.
So that's why it is economical. Scalable, कितना भी हम स्केल कर सकते हैं, as we have told, like scale out mechanism. दो मैकेनिज्म होते हैं, एक स्केल इन और एक स्केल आउट. स्केल इन का मतलब होता है जैसे कि हमारा सर्वर है, तो सर्वर या फिर आप, लेट्स वेरी सिंपल एग्जांपल, आपका फोन है, ठीक है? लेट्स से यू हैव गॉट अ फोन विद 8 GB रैम, 256 हार्ड डिस्क, राइट? जो आपका रोम है. So if you want to upgrade it, तो आप क्या करोगे? आप 8 की जगह 16 GB रैम ले लोगे और 256 जगह एक और अगर स्लॉट है आपके पास, so you can put one more 256 GB, तो आपका 512 हो जाएगा. But can you make it to from 512 to from 256 to 1 TB? आप लेके जा सकते हो, या आपकी जो रैम है वो 8 GB से आप 32 GB 32 GB लेके जा सकते हो? नहीं कर सकते ना, क्योंकि आप कोशिश करो, बट योर चिपसेट, जो उसका चिपसेट है, दैट इज नॉट गोइंग टू अलाउ इट, राइट?
यस सर.
एक लिमिट के बाद अगर मुझे अपना लैपटॉप, लेट्स से मुझे अपना लैपटॉप अपग्रेड करना है, आई हैड अ लैपटॉप विद 8 GB रैम, 512 GB, अब वो मेरा फुल हो गया है, आई नीड प्रोसेसिंग थोड़ा स्लो हो गया, सो आई नीड, तो मैंने अपनी रैम को बढ़ा दिया, 8 to 16 कर दिया, बट मैं 16 को 32 नहीं कर सकता बिकॉज उसको अलाउ नहीं करेगा, ठीक है ना? चिपसेट अलाउ नहीं करेगा, उसके लिए उसकी कॉम्पेटिबल चिपसेट भी चाहिए, प्रोसेसर भी तो उस लेवल का होना चाहिए ना, दैट इट शुड बी एबल टू प्रोसेस इट. सो दिस इज कॉल्ड स्केल वर्टिकल, कि हम एक लिमिट, वर्टिकली हम एक लिमिट तक इंक्रीज कर सकते हैं, बट हॉरिजॉन्टली में देयर इज नो लिमिट, लाइक, क्योंकि हम यहाँ पे क्या कर रहे हैं, हम यहाँ पे स्टोरेज के साथ साथ प्रोसेसिंग भी तो इंक्रीज कर रहे हैं ना, विच आर गोइंग टू रन पैरेलली. सो अगर आपने 1000 से स्टार्ट करके आप 12,000 तक भी ले गए, सो देयर इज नो नीड, क्योंकि वहां पे हम दोनों चीजों को लेके जा रहे हैं. हमारा जो सीपीयू है, सीपीयू में दोनों चीज है ना, हार्ड डिस्क भी है और प्रोसेसिंग भी है, प्रोसेसर भी, रैम भी है, राइट? तो हमारा पैरेलली रन करेगा, ठीक है? फ्लेक्सिबल इन द सेंस कि हमारे जो ट्रेडिशनल सिस्टम्स है, सर्वर्स की बात करते हैं, SQL सर्वर हो गया, MS SQL सर्वर हो गया, या फिर हमारा Oracle है, they work on structured data sets or up to some level semi structured, like you can also work with JSON data, or you can also work with XML data actually. But if you come to audio, video, images, or human readable text directly, it's not going to work directly, right? For that we need some sort of systems, or that is going to add a lot of complexity. So that's why it's, but जो हमारा Hadoop है, that it can work on structured, semi-structured, unstructured, any kind of data formats it can work. Clear? Reliable. अब ये तो बताओ यार, reliable, why it is reliable? Arvind, Devesh, why it is reliable?
बिकॉज सर ये चीपर भी है, फ्लेक्सिबल भी है,
हाँ,
इजी प्रोसेसिंग भी है,
but reliable
इसलिए
क्यों
ये
है? Reliable क्यों है? Because of data replication, right? कि अगर मेरा एक मशीन डाउन होगा तो आई कैन गेट द सेम डेटा फ्रॉम अनदर मशीन. अगर मेरे दो डाउन होते हैं तो आई कैन गेट द सेम डेटा फ्रॉम द अनदर मशीन, राइट?
यस,
सो दैट्स व्हाई इट इज रिलायबल. तीनों की टाइप पे डाउन होंगी. दिस चांस इज वेरी रेयर, राइट? रेयर ऑफ द रेयरेस्ट चांस. गॉट इट? अंडरस्टूड?
यस सर, यस सर, यस.
Okay. अब clear है ना? Reliable, economical, scalable and flexible. Reliable because of data replication, economical because of commodity hardware, scalable because we can add any number of machines whenever required, and flexible because it can perform operations on any kind of data. There is no fixed type of data that we should work upon, right? Any kind of data is coming, we are able to process that, right? So अब अगर हम Hadoop डिजाइन प्रिंसिपल्स की बात करते हैं तो वो क्या हुआ कि हमारा Hadoop facilitates storage and processing of large data set, rapidly growing data sets. Large और या rapidly growing है, structured हो, unstructured हो, any type of data with simple programming model. It offers scale out rather than scale up. I told you scale in, scale vertical, दोनों का मतलब सेम होता है. Scale out और scale horizontal both are same, right? तो हम बोलते हैं scale out या फिर scale horizontal, it means the same thing, और scale up और scale vertical same thing. Here we are bringing data rather than data to code. हम यहाँ पे कोड लेके आ रहे हैं डेटा के पास, ना कि डेटा को कोड के पास लेके जा रहे हैं, राइट? क्योंकि we are bringing processing to the data. We are not sending data to processing, right? क्योंकि डेटा को प्रोसेसिंग के पास सेंड करना, इट इज अ वेरी वेरी कॉस्टली प्रोसेस, जो हम देख चुके हैं, राइट? We have already seen कि उसमें 3 प्रॉब्लम्स आई थी जब हम डेटा को भेज रहे थे प्रोसेसिंग के लिए. क्योंकि हमारा जो प्रोसेसिंग है, दैट इज जो प्रोसेसिंग का कोड है, वो हमारा केबी में भी हो सकता है, एमबी में भी हो सकता है, और मैक्सिमम गया तो इट विल गो टू जीबी ओनली. ठीक है ना? अभी आप देखोगे, क्योंकि अभी अरविंद तो पढ़ ही रहे हो, बट इवन देवेश, आप यू हैव ऑलरेडी वर्कड इन Oracle itself. So वहाँ पे अगर हम कोई सी डेटा को प्रोसेस भी कर रहे हैं, ठीक है ना, तो क्वेरी कितनी बड़ी हो सकती है? 2000 लाइंस की क्वेरी हो सकती है. So it will go in maximum in in MBs. बट मैं मान रहा हूँ ओके, इट कैन ऑल्सो बी इन जीबीज ऑल्सो, अगर हम पूरी फुल एप्लीकेशन की भी बात करते हैं. बट स्टिल इट नॉट गो बियॉन्ड दैट. सो दैट्स व्हाई हाई स्केलेबिलिटी है, बिकॉज वेन एवर वी वांट वी कैन स्केल and it will be always available. क्योंकि highly scalable है, तो all the machines are not going to be down at the same point of time. So my data will be always, my system will always be available. एक गया तो दूसरा होगा, दूसरा गया तो तीसरा होगा, और तीसरा जाएगा. इसके chances बहुत rare है. I'll tell you why. We'll reach out to that point. Here we are using commodity hardware, so it is cheap and fault tolerance because of this, replications. क्योंकि एक तो है नहीं. So that's why it is always going to be fault tolerant, right? अभी थोड़े देखो differences हैं. Try to understand these differences. RDBMS यानी कि जो हमारे ट्रेडिशनल सिस्टम्स थे, वो स्ट्रक्चर्ड डेटा टाइप पे काम करते हैं, बट Hadoop कैन वर्क ऑन मल्टीपल ऑन स्ट्रक्चर्ड डेटा सेट्स. प्रोसेसिंग की बात करते हैं तो यहाँ पे हमारी जो प्रोसेसिंग है लिमिटेड है, और नो डेटा प्रोसेसिंग. लिमिटेड मीन्स लाइक वी कैन प्रोसेस अप टू सम GBs, terabytes, even process. But here my processing is coupled with data, right? जहाँ पे हमारा डेटा है वहीं पे हम अपनी प्रोसेसिंग को लेके जा रहे हैं. सो we can process as many number of nodes we want to process. We can add more number of nodes. Structured और standards की बात करते हैं तो यहाँ पे governance बहुत RDBMS में already defined structures पे, but Hadoop हमारा loosely structured है. So if new things are going to be there, those are easily accommodatable, right? अब उसका next point है schema required on write, but Hadoop में we required on read itself. So, ये आपको समझ में आता है स्कीमा का मतलब रिक्वायर्ड ऑन राइट. सो RDBMS में आपने टेबल क्रिएट करी है कभी?
यस सर.
टेबल क्रिएट करी होगी ना, क्रिएट टेबल, टेबल नेम, फिर उसमें
Yes,
हम बेसिकली उसका डेटा टाइप पास करेंगे, आईडी जैसे नंबर, नेम, स्ट्रिंग, और उसका हम साइज डिफाइन कर देंगे, व्हाटएवर इट इज, राइट? एंड देन वी हैव क्रिएटेड द टेबल. अब मुझे उसमें जब मैं डेटा डाल रहा हूँ, व्हेन आई एम इंसर्टिंग द डेटा, सो मैं डेटा कैसे डालूंगा? इंसर्ट इनटू टेबल नेम. अगर मैं एक रो की बात करता हूँ, इंसर्ट इनटू टेबल नेम वैल्यूज. अब वैल्यूज में मैंने इंटीजर डाला है आईडी में, तो मैं 1 2 3 4 कुछ करके डालूंगा, राइट? अगर मैंने उसमें डाला लेट्स से ABC, सो विल इट अलाउ? विल इट अलाउ?
नो सर.
एरर दे देगा ना?
यस सर.
तो इसका मतलब क्या हुआ कि जब हम स्कीमा जब हम राइट कर रहे हैं तो वो स्कीमा चेक कर रहा है कि भाई सही कॉलम में सही चीज जा रही है कि नहीं जा रही है, राइट? अंडरस्टूड?
यस सर. यस.
तो वो क्या करता है कि राइट करने से पहले ही स्कीमा चेक कर रहा है. सो दिस इज RDBMS में रिक्वायर्ड ऑन राइट का मतलब है कि स्कीमा वैलिडेशन इज रिक्वायर्ड ऑन राइट. जब हम डेटा को टेबल में एंट्री करा रहे हैं, at that point of time only we are trying to validate the schema, और जब validate होगा तो ही हमारा टेबल क्रिएट होगा, तो नहीं होगा, राइट? टेबल क्रिएट नहीं, टेबल में डेटा जाएगा, राइट? बट Hadoop में क्या है कि Hadoop में we are dealing with huge amount of data. अब हमें नहीं पता क्या डेटा आ रहा है, तो हम क्या कर रहे हैं उसको रिक्वायर्ड ऑन रीड. जब हम राइट कर रहे हैं वी आर नॉट चेकिंग एनीथिंग, जो भी आ रहा है रखते रहो, क्योंकि हम एक बेसिकली एक स्टोरेज जो है हमारा यहाँ पे बहुत चीप स्टोरेज है, राइट? तो हम डेटा को डंप करते जा रहे हैं, ले आओ. जैसे कि आपने देखा होगा ना, जैसे वेयर हाउस होता है किसी का भी, तो वेयर हाउस में हम क्या करते हैं, वहाँ पे पाइल अप करके रख देते हैं कि भाई पहले डेटा को ले आओ, बाद में देखेंगे, अभी फिलहाल यहाँ पे डाल दो, ठीक है? हम इसको बाद में देखेंगे, एज पर अवर रिक्वायरमेंट हम उनका फिर बेसिकली प्रॉपर स्केड्यूलिंग करेंगे कि भाई अच्छा ये सबसे अच्छा वाला ये यहाँ जाएगा, फिर ये उसके बाद वाला ये यहाँ जाएगा, ये उसके बाद वाला ये यहाँ जाएगा, ठीक है ना? पाइलिंग हम बाद में करेंगे, ठीक है ना? सो दैट्स व्हाई Hadoop में हमें रिक्वायर्ड ऑन, जब हम रीड कर रहे हैं कि भाई मुझे कौन सा डेटा रीड करना है, तब मैं उसको वैलिडेट करूंगा, ठीक है ना? डेटा को राइट करने पे मैं Hadoop में वैलिडेट नहीं कर रहा. राइट करने पे तो मुझे जो भी आ रहा है डेटा को राइट कर दो, ठीक है ना, लिख दो. बट जब मैं उसको रीड करूंगा तब मैं वैलिडेट करूंगा कि अच्छा सही डेटा ले रहा हूँ, रीड कर रहा हूँ कि नहीं कर रहा हूँ, ठीक है ना? सो दिस इज द डिफरेंस. अब जहां पे हमारा वैलिडेशन हो रहा है, तो वैलिडेशन जहां हो रहा होगा वो थोड़ा एक्स्ट्रा टाइम लेगा ना वैलिडेट करने के लिए. सो इसीलिए जब RDBMS में हमने रिक्वायर्ड ऑन राइट था, तो उसने ऑलरेडी जब टेबल में डेटा राइट किया, वैलिडेट कर लिया, तो यहाँ पे रीड्स फास्ट हो जाएंगी, राइट? बट Hadoop में वो वैलिडेट नहीं कर रहा है, जब राइट कर रहा है तो राइट्स फास्ट है, तो रिक्वायर्ड जो रीड है वो स्लो हो जाएंगी. अंडरस्टूड? आया समझ में भाई?
यस सर.
बोलते रहा करो इधर, मुझे लगता है कि सोच तो नहीं गए.
नहीं.
सो मत जाना, बता देना जब लगे कि हाँ इट्स गोइंग बियॉन्ड योर लिमिट्स. वैसे मैं अभी इसको यहीं पे स्टॉप कर रहा हूँ आज के लिए. दिस इज गोइंग टू बी आवर लास्ट टॉपिक फॉर टुडे. अब सॉफ्टवेयर लाइसेंस की अगर हम बात करते हैं तो कोई भी RDBMS है, नो नथिंग इज फ्री. लाइक इवन MySQL अगर आप बात करोगे वो सिर्फ ट्रेनिंग और स्मॉल डेटा सेट्स के लिए फ्री है. बट इफ यू आर वर्किंग ऑन एन और इन एन ऑर्गेनाइजेशन, सो वहाँ पे आपको लाइसेंस की जरूरत पड़ती है. हाँ, कॉस्ट कम होगा बट स्टिल इट इज गोइंग टू टेक सम सॉर्ट ऑफ कॉस्ट. बट Hadoop में क्या है, यू डोंट नीड टू पे फॉर लाइसेंसेस. ओनली इफ यू वांट द सपोर्ट then you have to pay, and that is going to be very bare amounts, right? रिसोर्सेज की बात करते हैं तो RDBMS में नोन एंटिटीज है कुछ. अभी तो मैं पिछले 20 साल में मैं जो देखा है वहाँ पे देयर इज नथिंग न्यू हैज बीन एडेड एज अ पार्ट ऑफ RDBMS. वही सारी चीजें हैं, वही टेबल है, वही कंस्ट्रेंट्स हैं, नथिंग हैज बीन एडेड. बट Hadoop में I have seen a lot of changes, growing complexities, और that they are able to accommodate. अब बात करते हैं कि भाई हमारा RDBMS is going to fit where it has to be used. OLTP, ऑनलाइन ट्रांजेक्शन प्रोसेसिंग. अभी भी हमारी जितनी भी ऑनलाइन ट्रांजेक्शंस होती हैं वो हमारी RDBMS में होती हैं. Hadoop कैन नॉट परफॉर्म. कॉम्प्लेक्स इसी ट्रांजेक्शंस हो गई, ऑपरेशनल डेटा स्टोर्स हो गए, दोज आर देयर एज अ पार्ट ऑफ ऐसे ट्रांजेक्शंस. यू मस्ट हैव remember like atomicity, consistency, isolation and durability. अगर ये चारों की चारों सीक्वेंस में कंप्लीट होंगी तभी हम एक ट्रांजेक्शन को कंप्लीट मानते हैं, राइट? अगर इनमें से एक भी मिस हो गई सो दैट ट्रांजेक्शन इज गोइंग टू फेल, राइट? अगर हम Hadoop की बात करते हैं तो कहाँ पे यूज होता है? डेटा डिस्कवरी, या हमें अनस्ट्रक्चर्ड डेटा को प्रोसेस करना है. व्हेन वी आर हैविंग ह्यूज अमाउंट ऑफ डेटा, उसको प्रोसेस करना है, देन वी आर गोइंग टू वर्क ऑन Hadoop, राइट? तो ठीक है, टुमारो विल सी Hadoop इकोसिस्टम. अभी मेरे को बताओ कोई भी तुम्हें डाउट है, कोई क्वेश्चन, कोई क्वेरीज, कुछ भी जो तुम्हें लगता है कि आई शुड डिस्कस दिस विद यू राइट नाउ. मैं ये जितने भी स्लाइड्स हैं आई एम गोइंग टू शेयर. ऑलरेडी मैंने शेयर किया हुआ है. इफ दे डोंट हैव आई कैन अगेन शेयर, बट मैंने ग्रुप में शेयर की हुई हैं ये सारी चीज़ें, ठीक है ना? तो दे विल सेंड इट टू यू. अदरवाइज आई
सर
कैन
अभी एक बार और शेयर कर देना.
क्या कह रहे हो?
एक बार और शेयर कर लेना.
हाँ, वो मैं शेयर कर दूंगा, नो वरीज. ठीक है, जो हमारा भी एक ग्रुप बनाया ना उस पर मैं अभी शेयर कर देता हूँ, या अभी कर ही देता हूँ बाद में, मैं भी भूल जाऊँगा.